This video will show the experimental setup section for the 820MO organ bath system using muscle strips. We will isolate an EDL from a mouse and mount it in the 820MO chambers. We will then find the optimal voltage and optimal preload for this tissue, as well as a few stimulation responses. We are unable to show the muscle isolation from the animal. However, you want to expose as much of the tendon as possible and never touch the muscle, only the tendons. You may need to keep the muscle wet with PSS buffer during your dissection. You should transfer the muscle to the 820MO chamber by only touching the tendon. When mounting your muscle, lay one end of the tendon over the clamp's edge. When you are ready to clamp the tendon, push down on the back edge of the plate, which will bring the front edge up. You may need to loosen the screw so you have flexibility to adjust the height of the plate. You can then swing the plate over above the tendon and clamp straight down on the tendon itself. Once you have the tendon and plate in place, you can tighten the clamp using the screwdriver. Only use 2 fingers. You do not need to over-tighten the screw. You should then adjust the distance between your 2 mounts so that you can easily place the tendon over the second clamp's edge. Place the remaining tendon over the edge of the clamp. Now move the plate in position over the tendon. Secure the plate by tightening the screw. Make sure there is still slack in the strip when you take it back to the interface. You do not want to stretch the muscle strip at this time. After you have mounted your tissue, you can bring the chamber back to the interface, plug it in, and start bubbling. You can start lab chart during the 10-minute rest period. After 10 minutes have passed, you need to find the optimal voltage for your tissue. You should place 1 millinewton of tension on the strip. After adding our millinewton of tension, we will now start using the stimulator. Make sure to turn on the channels on the stimulator. In this case, we will be using channel 1. You can go to the force voltage menu on MyoPulse, select the appropriate channel and the base voltage that you will start with. We will start with 8 volts, use a pulse width of 20 milliseconds, and do an incremental voltage increase of 1 volt. When you are ready, press the plus button. After 15 seconds, you can give it another pulse. You will continue these pulses until you no longer see an increase in the force response. You can see that we are no longer getting any increase in force response. So we can feel comfortable using 16 volts as our optimal voltage. After finding our optimal voltage, we can now find our optimal preload. We will use the optimal voltage we just found in order to help us find our optimal preload tension. Select Configure Channels. This will allow you to make changes on all channels you are using. In this case, we are only using 1 channel, so it will not make a difference. Select Single Pulse, and then Next. We will use a bipolar pulse shape. The pulse voltage we will use is 16 volts, determined from our optimal voltage. We will stay with a pulse width of 20 milliseconds. Select Next. We will start the channel manually. And digital out will not matter for this, but we will change that to not used and then next. The final page will give you a summary and select Finish. We will begin by using the same tension we were previously under. Give it a single pulse using the play sign above channel 1. So we will add 1 millinewton of tension before our second pulse. We've added our tension and we can give another pulse. So in this instance, we will decrease tension by half, 0.5, and we will try the pulse again. For your own tissue and your own experiments, you should work with different preloads and different starting points in order to find the best point for your tissue. We have found our optimal preload and our optimal voltage. The final step is to check your electrode positions. You can slide the electrodes on the chamber cover to try a couple different spots to see if you get a different response. We will give it 15 seconds and try our second position. At this point, the tissue and the system are ready for the experiment. For today's video, we will just show a few continuous pulses. You can set up your pulses by going to Configure Channels. Today we will use a continuing pulse. We will use our pulse voltage of 16 volts. We will keep the pulse width the same of 20 milliseconds. We will keep the pulse interval at 60 milliseconds. Your pulse frequency will be calculated from these values. Select Next. We will keep these the same. Select Next and Finish. We will use channel 1, but you can select Start All Channels as well. Either option is fine. We can stop the voltage. This is an example of fatigue testing. You can see the responses are diminished as we give it continuous pulses. For fatigue and other studies, you can also use a pulse train. Under Configure Channels, you can select Pulse Train and how many pulse groups you would like to use. Once you go to the next step, you can select a setup for each group of your pulse train. You can use varying protocols for each group in order to try different conditions. For more information on the 820MO system, please refer to the DMT website or additional resource videos.